Hello, this is Jack Jackson. In this video, we're going to look at some special forms that certain types of limits may obtain, and we're going to see some of these we know what's going to happen with the limit. Either we know the limit exists, or in some cases we know the limit doesn't exist, but it goes to infinity or minus infinity. In other cases, we don't know anything about it whatsoever. And so let's look at these. So the first one says if you have the limit of f of x approaches 0 and the limit of g of x as x approaches c goes to 0 as well, then the limit of the sum is 0. And that's just a straightforward application of one of our, I think that's our first limit law. So that's an easy one there. If the limit of f of x as x approaches c is some real number constant, so k could be any real number, and the limit of g is infinity, then the limit of that sum is also going to go to infinity. Now we can't really use the limit laws because directly because the limits of the two parts don't exist, particularly the limit of the g part doesn't exist. But nevertheless, if this part is going to a constant and this part's going to infinity, the sum's going to go to infinity. And likewise, if the limit of one part's going to a constant and the other part's going to negative infinity, then the limit of that sum will go to negative infinity. Okay. If both parts are going to infinity and you're adding them together, then certainly the whole thing's going to go to infinity as well. If the limit of the first part is going to, well, if they're both going to minus infinity and you add them together, then that goes to minus infinity. And the next one says that if the limit as x approaches c, let's say just from the right side of f of x is a constant, and some real number there, but the limit from the other side is 0, and you're dividing this constant, the top's going to a constant and the bottom's going to 0, then that one-sided limit will either be infinity or minus infinity. It will not exist. So the function will have an asymptote in that case, a vertical asymptote. Similarly, if you're taking the limit from the left and the numerator of your fraction is going towards some real number, but the denominator is going towards infinity, go to 0, then the whole thing's going to either go to infinity or minus infinity. Next, if we have something where the first function is going towards, as x goes to a constant, is going towards a limit of 0, and then we have a limit of k, some constant here, and we're multiplying those two, we'll get 0 for the limit. Now if we have a constant that's not 0, and we have one is going to infinity and the other one's going to k, then that will go to infinity. But be careful because it might be infinity or minus infinity. It depends on what's going on here. So, and again, we should probably talk about this only as a one-sided limit here. So if we do a limit as x approaches c from the right side, for example, and this one's approaching positive infinity and this is approaching some constant, then it might go to infinity or minus infinity. It depends. Same way here from the left side. And here, if you're going to minus infinity and then the other one's going to constant, again, this could go to positive or negative infinity. It depends on the case. And next, if we have a limit as x goes to c is going to infinity, at least from that one side, say from the right side, and the other one's going to 0, if the top is going to infinity and the bottom is going to 0, then the whole thing's going to go to infinity or minus infinity. Okay, but if, well, all these are variations of that same thing. This next one says if f of x is approaching k, when you take the limit as x goes to c, and g of x is going to infinity, where the numerator is going to some real number, and the bottom is going to infinity, the whole thing is going to go to 0. And the next one says if the numerator is going to 0 and the denominator is going to infinity, plus or negative infinity, the whole thing is going to 0. That works up here. It's a special case of this one up here, just when k is 0. Now this is kind of interesting here. We haven't encountered one like this yet, I don't think, at least not in my videos yet. So if we let x go to c of f of x is a constant, some real number, actually has a limit, and g of x is approaching infinity, it does not have a limit. So with this thing will go to infinity if that constant, if that base is going to a constant real number that's greater than 1. If it's going to a base that's less than 1, then the whole thing's going to go to 0. And if it's equal to 1, we don't know what it's going to do. And this is kind of the same thing here, except this time the power is going to negative infinity. It just kind of goes backwards here. So if the base is of this, the f of x is going to some real number bigger than 1, and the top is going to negative infinity, then the whole thing's going to go to 0. And if the base is going to something less than 1, and the top is going to negative infinity, the whole thing is going to go to positive infinity. But again, if that base is 1, we don't know what's going to happen. So I can kind of informally state these things like this. 0 plus 0 is 0, of course. K plus infinity is infinity, meaning what I'm actually saying over here. This is sort of a shorthand for it. K minus infinity is minus infinity. Infinity plus infinity is infinity. Negative infinity plus negative infinity is negative infinity. A real number divided by 0 is going to go towards infinity or negative infinity, at least from one side. Possibly both infinity, possibly both negative infinity, possibly infinity from one side, negative infinity from the other side. 0 times constant is 0. Plus or minus infinity times k is plus or minus infinity, but not necessarily the same one. So this is plus infinity, this may be plus or minus infinity. And this is if k is not 0. Okay, so for a non-zero number for k. Plus or minus infinity divided by 0 is infinity, but again, it could be positive or negative infinity, depends on, and it might be 1 from one side and something different from the other, and not necessarily the same, so plus infinity doesn't mean plus infinity here. It's stated more specifically over here, of course. This is just a shorthand to help you kind of maybe remember it. And k over plus or minus infinity is going to go to 0. 0 over plus or minus infinity will be 0. K to the infinity will be infinity if k is bigger than 1, and k to the infinity will be 0 if k is less than 1. K to the minus infinity is 0 for k bigger than 1, and k to the minus infinity is infinity for k less than 1. So that's just shorthand for that. But within all this, we think, well, maybe we got them all. Well, no, there's some things that we just don't know. And so here we have some informal situations. So if we ever get infinity minus infinity, we don't know. I did not fix these. Infinity minus infinity is unknown. Okay. Well, all of these are question marks. Let me just get rid of that part of that. Yes, I think I've got them all right now. Okay. So what I mean by that is if you take the limit as x goes to c of f of x is infinity and limit as x goes to c of g of x is minus infinity, then you have no idea what the limit of the sum is. In fact, we can make up examples where that sum goes to infinity. We can make up examples where it goes to 0 or it goes to 1 or any other number we want. And then we can also make up examples where it goes to minus infinity, or we can make up examples where it's just undefined. We just don't know what it is. So this is totally inconclusive. It's in what we call an indeterminate form. It might be anything. Okay? If the f of x goes to either infinity or minus infinity and the g of x goes to 0, then we have no idea what the product is. So plus or minus infinity times 0, not necessarily 0, not necessarily infinity, could be anything. And it could be anything besides 0 infinity. We just don't know. Similarly, if f of x goes to 0 and g of x goes to 0, but then we're dividing, so we get sort of 0 over 0, we have no clue what that could be either. That limit could be actually anything. And in fact, that one in particular is very, very common in the study of calculus because every derivative basically has this form to begin with, and you have to work out with that. And derivatives are one of the main two branches of calculus that we're going to be studying. starting next week in our next unit. This one here, when we're doing some powers, if the base f of x is going to 0 and the power g of x is going to infinity or negative infinity, 0 to the infinity, 0 to the negative infinity is another one we don't have a clue what that is. And a lot of these involve zeros and infinity, but powers 1 becomes a problem too. 1 to the infinity or 1 to the minus infinity is also something we don't have a clue what that is either. So if the limit of the base is 1, the limit of the power is either infinity or minus infinity, no clue what that's going to do. Again, there's all kinds of, I can make up or show you examples where this limit might be 4, it might be 7, could be 0, could be infinity. We don't know. It just could be anything. So it requires more work, right? And so this one says if the base is infinity or minus infinity and the power is 0, 0 to infinity to 0 or negative infinity to 0, again, we don't have a clue what that could be. Or infinity to the first power, if the power is going to 1 and the base is going to infinity or minus infinity, we don't have a clue what that is. So anytime you get something that's one of these forms, you know you got more work to do. You can't just sort of cut to the chase and get there. Now these forms up here, yeah, those are a little bit better. These forms up here we can do something with. In fact, we even know what we're going to end up with. But these forms down here are indeterminate forms. So what do you do in those cases? Well, you got to manipulate it somehow into some other form. Usually that involves some algebraic manipulation, some little trick or playing around with it to get it in a different form. So some sort of algebraic manipulation, and then get it in some form where we can apply our rules to it. Now, technically, I should go through and prove all these things. I may or may not do that in another video, but for right now, we're going to leave this video at this point.